Hello there. Welcome to today's episode. We are on episode number 3. Today we're going to cover the following topics. All the timestamps are in the description below, and I hope you do enjoy today's episode. Did you know that PowerShell has a package manager that you can use to install modules that you can use to add functionality to PowerShell? For example, we are aware that there is a NuGet package manager, and we are aware of there is a chocolatey package manager. So let's take a look at the difference. So PowerShell package manager is called PowerShell Gallery. So here you can see the PowerShell Gallery, and this is how you use the install module command. And this is used for PowerShell scripts and modules. So yes, but it can't be used for NuGet packages. It can't be used to install software using chocolatey. For .NET libraries, you use the NuGet package manager. Here, chocolatey, again, you cannot use it to install .NET libraries, but chocolatey can be used to install software and apps on Windows. And this is what the PowerShell Gallery package manager looks like. So we are here on the main website. And on here, you can see the search box and you can see the packages. So if you go here, you can see all the packages that are available. You can filter by script, by the operating system, or by the category. If I go back at home and if we search for Excel, for example, you can see the following modules, and some of them you can see some are modules and some will be scripts. So here, this is a script. So this is the handy function to creating a temporary blah. You can see here different packages that people have released. So this is a popular one, but 11 million downloads is called Import Excel. It's a module to import Excel spreadsheets without Excel. So you don't need to have Microsoft Excel installed for this package to work. So here, you can go here and find out more details, such as who the author is, the different versions. So this one was released 5 months ago, and you can go into the project website. So here it will take you to the GitHub page, and then you can find out more how it works and so on. Then there are 100 examples here on how to use it, and here the quick example on how to use it and how to export data from PowerShell. But it's a PowerShell variable here, and we're just exporting that out into Excel. Now this runs without installing Microsoft Excel. So this is the main website, and you can, of course, if you wanted to download this manually, then you can click on manual download and download it. But a better way is here the command that you can copy, install module, name, import Excel. So we'll now just go back to our coding window in Visual Studio Code, and let's have a look at this. So here you don't have to use the website. You can just use find module command here. And if I run this, and you can see that after a short while it's loading, and we will now get the output here. So you can see all the different modules, and you can see one of them is called import Excel. This is the repository, so we're going to get from this package manager PS Gallery, and this is a small description about it. And you can see all the modules that are currently installed on the system. So if I run this command, and you can see all the packages that are installed. So here we have modules that are installed here. So this is within the VS Code directory, but there are other modules here which are installed in this directory here, System32. And of course there are more here which are installed within C program files, Windows PowerShell. So here you have more modules installed and stuff like Azure and so on. So these are the default modules that you can install. So you can check if what module is available installed locally. So by running this command, so just check are any modules that are installed for Excel. If I run this, and as you can see, we don't get anything back, so there's no package available that is for Excel. And we can install that, and we can add scope current user. So this will install the module just for the current user. You don't need administration rights in order to do this, so because it will install it in your user profile. So if I run this, and it will come up with a message to say you're installing this, do you trust the source? So we're going to say yes. So if I type yes, YM here and press enter, and you can see it's installing the package. So it's installed the package there. And now if we list the module, and you can see here the import module is installed. This is the version that's installed, and you can see where it's installed. So it's installed in the user profile here. So you don't need administration rights for this, and you can uninstall the module by simply running this command, and you can see that it will now remove that module that's loading, and there you go. It's now uninstalled. So if we search for it again, and you'll find that it's no longer available and it's no longer installed. So begin to install it, you just run this, and it will just ask to confirm, and you just say yes, and it's installed. And now if we list the available modules, you can see that we now have right at the top of this, we have within this directory the Excel module installed. So this is the user directory. So I hope this makes sense. So the package manager PowerShell Gallery is used for PowerShell scripts and modules that is similar to NuGet package manager, chocolatey, or the package managers you have for Python or Java, NPM, and so on. So just remember these commands: find module, get module, install module, and uninstall module. In Windows, PowerShell is then stored in the following folder, and you can see it's stored in this folder here, version 1. And if I go back one, and you can see that it's only version 1. The reason it's version 1 is for backwards compatibility. So when you run PowerShell, you will actually get version 5. So if I run this here, and as you can see here, we are launched from version 1. But if I do PowerShell version, you will see it's actually version 5, even though it's installed in version 1. The reason is for backwards compatibility, and that's why to this day there is no version 2, version 3, 4, 5. Instead, Microsoft just updated version 1 folder. So that could be misleading and quite confusing. But remember, you're actually running version 5, even though it's installed in version 1 folder. PowerShell comes in 2 different flavors. One, which is 64-bit, and is installed within C Windows System 32. And the other one, which is 32-bit, is stored within C Windows Sys WoW 64. And then within the same folder structure there. So why would you want to use 32-bit versus 64-bit? First of all, let's see the difference between them. So if I run the 64-bit here, and you can see it doesn't indicate anything around 64-bit within here. But what you can do is, using the .NET class environment, you can access the static method. The 2 colons indicate we're accessing the static method called is 64-bit process. This actually is a property that simply has the get method. So here, if I run this, you can see this returns true because it's a 64-bit process. But if I do the same thing with the 32-bit open PowerShell PowerShell. And again, as you can see, you can't tell whether it's 64-bit or 32-bit, but if you go here and run the same command for this class, and you can see it returns false. This indicates that this is not a 64-bit process. So this is actually what I mean by the processes. It's running within this terminal window. So why would you want to use it? So let's say you have an old Microsoft Access file that uses the get_db4. So if this command creates a COM object, Microsoft get_db4. So here, this driver is only compatible with 32-bit. So I'm currently in 32-bit here. So if I run this command here, and as you can see, it's been successful. So if I try and do that same thing within this version, which is a 64-bit, and you can see this is a 64-bit process. So if I run this here, and what will happen is it will cause an error. This is because it's not compatible with 64-bit version of PowerShell. So this is when you need to switch between 32-bit and 64-bit. Usually it's for legacy reasons, so this is something that you should be aware of, that Microsoft still to this day provides 32-bit support for the PowerShell version that's installed in Windows. So sysbow64 has the 32-bit, and the 64-bit is installed within the normal directory. I'm currently running Windows 11 64-bit, so that's why this default version is 64-bit, and in here we have the 32-bit. This is installed by default, so it's available to everyone. In PowerShell, you can use getChildItem to print directory listings. So here we've got getChildItem, and we're going to use the path parameter to give it a folder path, and then we're simply going to select the name and the full name. The full name is basically the path of the file. So if I run this, and as you can see, we've got 3 directories in here: C#, PowerShell, Python. Now, if I run this one, go 1 level deep, and as you can see, we now get a directory printed, but we go down 1 level deep. So that's what the depth parameter is. Now, you can use the recursive parameter. So here, what this will do is it will go through each file and folder and print them out in these directories. So everything within here, it will go and print that out. If I run this code here, and as you can see here, it's just going through all that and it's retrieving every single file. And then if you use the recursive with the depth parameter, you can then see that it won't go down that deep. So if I run this here, and then you can see the depth level now says only go down to 2 levels from the original path. So here, as you can see, this is the root, and we are level 1 and level 2, and it doesn't go down any further than that. Now, if you only wanted to retrieve the files rather than the directories, so notice here we just printed the directory names, then you can use the file parameter. So here, it won't now print the directory names, it will now print the individual files. So as you can see here, I've got different files that are printed, but no directory names are printed because we added the parameter file. And if you add the directory one, notice the difference that we only get folders. So this will be useful when you just want to retrieve folder names, or useful when you just want to print the file names. Notice we're using the pipeline operator here and a new line here. This is to break up your code. So as long as you add the pipeline operator here, then you can split your code up, but the previous line must end with the pipeline operator. So yeah, just remember, getChildItem is really useful to work with files and folders, and it comes with very useful parameters that let you retrieve only the folders or the files and let you specify how deep do you want to go. So you can use a basic one like this, or you can specify more parameters, including recursion, to pretty much print anything in the directory. So for example, if you wanted to print the directories in folder subfolders rather than 2 level deeps, just take out the depth parameter. And if you were to run this again, and you can see it will now print every single folder that is within the main root that you've specified here. So all of them here are within C shared projects. Did you ever want to search folders and files, but you've been using Windows search function? Instead, you should switch to PowerShell. PowerShell is really fast and really versatile. So here, just by using the simple command called getChildItem, you can specify parameters such as you want to use recursion. This is the file path parameter where you want to search, and then you can use the filter parameter here, and you can look for specific word in your files. So let me demonstrate this here. So if I run this code, you can see that it has retrieved all the files very quickly within all the directories that contain the letters try, DRY. So here you can see all the letters. Now, if you only wanted to retrieve folders rather than files, then you can just add another parameter called directory. So here, by adding directory, it will retrieve only the folders. So here I run this, and as you can see that there is only one folder here, which is called retry in this location. So this is much faster than using the Windows search. So just remember, getChildItem, recursive, you only want directory. This is the path that you want to look, that you specify the path parameter, and then use the filter parameter, and then you can use wildcards here to search for specific things. If you wanted to retrieve only text file, for example, if I take out the directory file parameter, and then let's say you only want to look for PowerShell files, then you can run this and you can see it's retrieved all the files that have the extension BS1 for PowerShell. So this is much faster than using Windows search. So make sure you use PowerShell getChildItem to search less your files and folders on Windows. In PowerShell, you use the getChildItem to retrieve files and folders in a directory. You use the path parameter to pass it a file path, and you use the recurse parameter to go through all the subfolders and files and store them as objects. Those objects would have all the properties properties that files and folders have, such as name, date modified, date create, and so on. Then you use the pipeline operator here to pass that onto the next function. So here, this commandlet where object takes the input from the previous one and individually goes through each item. Those items are then filtered. So within these curly brackets, we filter. We supply an expression. The $_ is the default variable that is automatically created for each item or each file and folder that was created in the previous step. And then we're going to do its name, like auto. So this again is a parameter, and we are saying we want it to match auto. You notice the wildcard. Then we take that input into the next pipeline and we simply do a select. So if you are from SQL background, you can just say from the previous object, just select name and full name, fields or properties. So if I run this here, and as you can see, we've got the output name and full name, and we've got all the files that contain the word auto. In PowerShell, you can find out a data type of a variable at GetType. So I've got a variable here called name. I want to find out what data type it is. So if I run this command, and as you can see here that I have string, and you can also see the base type. So this is a function that's available to the variable, but you can also get the information using pipeline. So here we've got a pipeline operator, and we're passing that over to the next commandlet or procedure. So this procedure will basically check or inspect the variable and print out its information. So I say get member, so we will get all the properties and methods. So if I run this here, and as you can see here, we've got the following printout, and at the beginning it says type name. So it's a string type. So here it returns the type as well, but it returns more information such as the method, and it tells you the definition as well. So here you can see which ones are method and which ones are properties. So here this is a property and it only has the get method. So there is no set method for this property. So this is a fantastic way of finding out methods that are available and also the definition of those methods. So here I have another variable called coins. So if I run this code here, and as you can see, we've got it's a int 32, but this command doesn't display any other information. That's pretty much it. But if we run this, and you can see we get wealth of information here. We get all the methods. So here you can convert this to a string, to int64, to decimal, to boolean. You can use how we use the GetType method. So here we use that, and it also tells you what data type it is. So this is a 32-bit integer. So just remember, you can use pipelines to get information about a variable, or if you just want to know its type, then you can simply run this and it will just give you the type information without any other information such as the methods and further properties. So I tend to use getMember because then you know what's available and what you can query. So I hope you found this useful to learn about GetType and getMember and the difference between them. In PowerShell, did you ever wonder what is the data type? Use pipelines to run commandlets. So here I've got a commandlet called getChildItem, which basically retrieves the file or directory listings. So I pass this with the command operator to the next object. What data type will it be? So you can find out the data type in two ways. So the first one is using getMember and then its properties. So here, if I run this command, and as you can see here, if I scroll to the top, and here we've got a type name. It says it's of system.io.file.info. So that's a data type that's returned by this getChildItem procedure or commandlet. So here, this commandlet basically takes that object and works out its properties, type, and its method. So here you can see we've got the following properties for this. So here you've got information such as the directory name, full file name, you've got last access time, length, and so on. And you can see what type of property it is, whether it's a get or a set property. So here you can actually modify the last write time because it's got a set property. So you know you can actually modify that property. So here, alternative way is you store that in a variable. So I'm just going to call that variable obj, and I'm going to run this command and then use the getType function. So let's see what that gives us. So I have run this, and as you can see here, it's that command getType has returned object at the type and is of type array. So why has that happened? It's because when we queried this file location, it has multiple files and folders. So that in turn is stored in an array, and that array is of type object. So how do we get to know when we had it's actually of type system.io.info? Because it's an array, you can access the elements like this, like the index notation. And here, if I run this command, and as you can see now, the first element, so wherever the first tile is, we can now see getType returns system.io.filesystem.info. So this is type file info. So this is the one that matches the earlier one we had here, file info, system.io.file.info. So there are two methods here. You can see you could get the overall type that's returned, but if you want to dig down, you could go down to the array, or you can use getMember, and it basically will just look at one of those items, so the first file and so on, and print its properties and methods. I prefer the getMember because it's just much easier to use. I hope you like this video and it have been useful for you. Did you know that in PowerShell, when you pass objects between different pipelines, does the data type change? So for example, here I've got getChildItem, which is basically going to give me a directory listing, and that is all system.io.file.info type. So here, when that gets passed around to this where object to filter it, and then into a select object to select only the relevant fields. So if I show you this bit here, so that you can see, we just get the printout here of the name and the full name and the creation time. Creation time can't be printed because the width of this isn't wide enough, so that's fine. But what data type would you get here? So if I run this command, and as you can see, we got the following data type. So we've got type name of selected.system.io.fileinfo. Okay, and then we've got the properties as well. So this is a property, and as you can see, it's given an example of that property too. So when items get transferred between pipelines, they tend to maintain the data type. But notice here, it has gone with selected because we use a select object. Whereas if you didn't use this, for example, if I take this out and run this, so here, if I scroll up, you can see is the type system.io.fileinfo. So slightly different, but it tends to maintain its data type. In previous video, I showed that PowerShell maintains the data type between pipelines as much as it can. So for example, here, you can see I'm using the select object as well as a where object. If I query this here now, then as you can see, it has returned all the properties, but it has returned the data type as selected.system.io.fileinfo. Whereas if you didn't use the select object, so if you take this out, then you won't get the word selected. So PowerShell tries to let you know what data type the original object was, but because you have removed some properties from the original, so here it just adds the word selected, because if you did this, such as, so you just pick one property from there, and if I were to run this, you can see it's just got one property, and that's the file main that it returns. So here it's added the word selected. But if you take this out completely, and you go directly from the where object, which doesn't necessarily modify the original data type. And if you query this now, you will get the data type, but without the word selected. So if I run this, and as you can see, we now get system.io.fileinfo, whereas previously we had selected.system.io.fileinfo. So the word selected have been added on when you use the select object in the pipeline. But in some instances, PowerShell doesn't maintain the original object type. So here we are actually, rather than using select object, we are changing the format completely of the data type that we got. The format table will modify the original object completely. It's a completely different structure. So if I run this now, and as you can see, we got the data type as Microsoft PowerShell commands internal format the end data. So this is the data type that we got, and it's got completely different properties, as you can see. So I hope this makes sense. Sometimes PowerShell will not maintain the original data type of an object, whereas in other instances, it will try and let you know what the data type was of the original object where it can. Now with select object, because you have modified and only selected one property out of the 20 or so that were available, you have modified it, but it still kind of shows you what data type it was. In this instance, when you format table, it is a completely different object. So I hope you found this useful in determining when is it likely the PowerShell will modify the object type and when it will not.